This unit will cover changing materials, and the first section will look at differences between physical and chemical changes. In chemistry, it's really important to sort out the differences between physical and chemical changes that happen to materials. So let's look at chemical change first. Chemical change is when a new substance is formed. Striking a match will result in a chemical change. The burning releases energy. New substances such as ash and charcoal are formed, and this change is not reversible. But other changes which do not involve a chemical reaction are called physical changes. For instance, ice here, when it melts, is a physical change. And though ice and water look quite different, they are still the same material and their mass remains constant. In the next few clips, we're going to see a lot of different changes. A typical test question would ask, in the following examples, which changes are physical and which are chemical? Why not jot your answer down as we go along? So, which changes are physical and which changes are chemical? How did you get on? Your answer should have 2 chemical changes and 2 physical changes. Let's run through them again. So with burning, the material changes in appearance and we can't reverse the change. So this is a chemical change. This is wax melting. We have a change of state that can easily be reversible. So this is a physical change. And this next one is also a physical change. Water vapour changing back into water. And the last one, cooking. Well, new substances are made and the change is impossible to reverse. So this is a chemical change. How did you get on? If you weren't sure, the key points will help you with physical and chemical changes. Let's look at chemical and physical changes. With a chemical change, a new substance is formed. Energy is released and the reaction cannot be reversed easily. With a physical change, no new material is made, the change is often reversible and the mass remains constant. The first type of physical change we're going to look at is dissolving, where one substance dissolves into another.
2 identical beakers of water, 2 identical piles of salt.
So the scales balance. But what will happen if I put this salt into the beaker?
That salt will go down, won't it? It'll be heavier. There'll be more weight with the salt in the beaker.
I bet it'll go down at first, but then go up again. No, you're both wrong. This side will go up because there's 2 things on that side and there's only 1 thing on this side.
Go on then, let's see. But they've still balanced. Why?
Why do you think the scales have still balanced? Let's find out.
Stella, can you try this?
Okay. The same thing happened when I tried it. They still balance because the salt is still there. It weighs the same when it's in the water as when it's in a pile next to it. But something else is going on here. Take a closer look at your experiment now.
Look, the salt's gone, but the scales still balance.
So even though you can't see the salt now, it is still there.
Because the salt has dissolved, it looks as if it has disappeared, but it is still there. Remember, when a physical change takes place, the mass remains constant. That's why the scales remained balanced. And this change can be easily reversed. Now, a tricky point about dissolving, all those S words.
When you're revising dissolving, there's no easy way around learning the terms. Solvent, solute, solution, soluble. Get somebody to test you on to make sure that you've got them right.
With solutes, solvents and solutions, the S words, a helpful tip is to remember that the solution is what you puzzle out at the end in a crossword. So the solution is what you make when mixing a solute with a solvent.
A solute is the substance being dissolved. The solvent is a liquid which the solute dissolves in. The solution is the mixture of the solute dissolved in the solvent. And soluble means that the substance dissolves in the solvent. You need to have these clear for your test, so why not stop the tape and practice writing all 4 of them down with some examples. That brings us to the end of dissolving. Can you remember the 4 S words and their definitions? This is a really key area that you need to know well before your tests. So if you're not sure, why not rewind to the key points? Another physical change is when materials expand and contract due to a change in temperature. Before the metal ball is heated, it easily falls through the ring. Now let's see what happens when we heat it for a few minutes.
So you see if it fits anymore? Okay.
The ball no longer falls through the ring. The metal has expanded. Let's look at that again at the particle level. What exactly happens when something expands and contracts? When a solid is heated, the particles inside it increase their movement, and the particles move slightly further apart, so the whole object expands. And the opposite happens if energy is removed by cooling. The particles decrease their movement, move closer together, and the material contracts. So expansion is where energy in the form of heat is added to a substance so it enlarges. Contraction is where energy in the form of heat is taken away, so a substance contracts and becomes slightly smaller. We are now going to take a closer look at changes that happen over millions of years. Besides physical and chemical changes to materials, there are also geological changes. Now, geological changes happen over millions of years, and we can summarise these changes in the rock cycle. The rest of this unit is going to look at the rock cycle and examples of the 3 types of rock that you need to know.
Volcanic rock is called igneous rock, and igneous comes from the Greek word meaning fire, and that's where it's coming from. Molten rock, hotter than fire. But how is it hot? The centre of the Earth, the core, is thousands of degrees Celsius. It's hot enough to make molten rock, which is what the next layer, the mantle, is made of. The Earth's skin, or crust, is anything from 5 to 75 kilometres thick. It's cooler, and so it's solid. Sometimes the molten rock pours out through volcanoes. This is brown sugar in water. When heated, it becomes like toffee. But when I pour it on this tray, it cools and solidifies like molten rock. And this is what happens with igneous rocks. Igneous rocks have a crystal structure, and the size of the crystals depends on how quickly the rock cools. The quicker it cools, the smaller the crystals.
So here are 2 examples of igneous rock. This is granite, which has small crystals because of fast cooling. And this is quartz, which has very large crystals due to the rocks cooling slowly. The next clip looks at sedimentary rocks, and these are made by a very different process.
Over the years, bits of sedimentary rock settle on the seabed because of gravity, and the layer gets to be very thick. And the thicker the layer gets, the more pressure is exerted on the bottom of it. As the particles get squashed, the water is squeezed out, leaving deposits that cause a process called cementation, where the particles are cemented together. Over time, the squashing and cementing of the sediment forms sedimentary rock.
So, sandstone and limestone are sedimentary rocks. They are grainy and crumbly, and sometimes they contain fossils. But ending up like this is not the end of the story for these sedimentary rocks.
After this sedimentary rock's made, the weight of the layers pushes them deep underground, where the earth can heat and squash the sedimentary rock further. Now, when it does this, the rock changes yet again, and this third type of rock is called metamorphic.
And it's this heat and pressure that give metamorphic rocks special properties. Slate and marble are metamorphic rocks. They are hard and smooth, and very small crystals in layers mean that they can be used for roof slates or tiles, or chiselled and polished into ornaments.
Both sedimentary and metamorphic rocks can work their way to the surface and be eroded by the weather and make their own rock cycles. The other possibility is that metamorphic rock can get heated and melted down, ready to be thrown out of the earth again to make igneous rocks. So the whole thing starts again. That's why it's called a rock cycle.
The rock cycle is an ongoing cycle of events over millions of years, where rocks at the Earth's surface are being continually broken down, reformed and changed. So examples of igneous rocks are basalt and granite. Examples of sedimentary rocks are sandstone and limestone, which are cemented together. And examples of metamorphic rocks are slate and marble, which have been compressed and heated. So, here's a test question. Bricks are made by baking clay. Which type of rock is formed in a similar way? So if bricks are made by baking, that means they're heated. So which type of rock is formed by heating? Stop the tape and have a think. So this question is just looking for the name of the rock, which is metamorphic rock, where the rock is compressed and heated, changing the way it looks. If you weren't sure of the answer, why not rewind the tape and run through the rock cycle again? This brings us to the end of this unit. We've gone through some physical changes that happen to materials, the rock cycle, and examples of the 3 different types of rocks. There are further questions in the Bitesize book and on the website. But if you've had enough, why not take a break before moving on? Between physical and chemical changes. In chemistry, it's really important to sort out the differences between physical and chemical changes that happen to materials. So let's look at chemical change first. Chemical reactions are called physical changes. For instance, ice here, when it melts, is a physical change. And though ice and water look quite different, they are still the same material and their mass remains constant. This unit will cover changing materials, and the first section will look at differences. Chemical change is when a new substance is formed. Striking a match will result in a chemical change. The burning releases energy. New substances such as ash and charcoal are formed, and this change is not reversible. But other changes which do not involve a chemical... In the next few clips, we're going to see a lot of different changes. A typical test question would ask, in the following examples, which changes are physical and which are chemical? Why not jot your answer down as we go along?